Cool. I believe you are now recorded. Hi everyone. My name is Chi Tran, and Kim. Together with me, we have Savio, the speaker for today. Savio is from Aztec. He's the product manager. But I will leave the introduction to him. Before we start, I would like to say thank you all for coming and a quick shield of what's coming. What's our biggest event that is coming up? It's going to be Ethereum Kuala Lumpur 2023. It's being organized by us, the ETL team. It's going to be an in real life hackathon plus conference event happening at the same time. It's going to be on the 13th to 15th of October. Sunway University, the venue is just amazing. The chairs are fantastic. We have received a lot of good feedbacks for the location in our past May event. You can join both as a hacker or as a participant. Hackers are free, limited to only 200 participants. We'll do a pre-filter. So that means we will want to make sure that the quality of the hackers are there. That means not everyone is able to join as hacker, unfortunately, but everyone is definitely able to join as participant. The ticket price is very cheap. It's priced at 50 ringgit MYR, which translates to around $11 US. Savio, have you seen a better price than $11 per ticket for a conference?
I mean, there are probably some of them that are free, but the good ones are always a lot pricier than this. So yeah, definitely exciting.
Yes, we want to make it for free, but we also want to gatekeep it so that people don't come for free food and free swag. That's why it's only $10, $11 US. I hope it's going to be very cheap and it's very fun. We do have a couple of confirmed speakers already. Caddy Saul, our past online speaker, is very supportive of the event. Caddy, if you're watching, thank you so much. And we have people from Elio, we have people from QuantStam, the founder of Etherscan is going to be here. Gnosis, OneSup, a very famous figure in the CK space. And we have Zhen Yu Yong from Web3 Foundation, from Web3 Off. Sponsors, we have a confirmed gold sponsor already from Elio. We have more will be announced soon, but the event is looking good right now. And I'm done talking. I would like to let Savio take it away. Take it away, Savio.
Dang, yeah, very looking forward to the event as well. It looks very cool. But yeah, let me try to share my screen. And good evening, everyone that is joining live, or good morning, good afternoon to whoever that is watching the recording. I'm Savio. I'm the product manager of Noir, the CK language that we are building in Aztec. It's just great to be here with everyone. Thank you, Chi, for the invite. Definitely excited for the Ethereum / developer community that is building up in Kuala Lumpur. It's been a while since I've been in Kuala Lumpur. I would say it's probably like 6 years ago, but I definitely still miss the Lo Shi Fan, the noodle kind of thing in Kuala Lumpur. So yeah, definitely miss the place and looking forward to visit it sooner rather than later if I get a chance. But today's talk is a brief introduction as well as an overview on CK dApps, if you have heard of it, more particularly on why, what, how do people write CK dApps or Web3 apps that are CK tied. The links of the slides will be shared at the end of the speech, so don't hustle too much on scanning the QR code right now and just enjoy the talk. So a brief rundown of the talk itself. We'll first go through kind of the pipeline to writing a CK dApp, following up with some of the components or technical thingies that are needed to manage our own private states. Following to that, we'll anchor the learnings concepts that we covered in part 1, part 2 into an example in part 3, and then following up with a brief glimpse of the exciting things that are both offered by Noir as well as that will be offered by Noir. Very exciting journey. Stay tuned for that. So let's kickstart things with the pipeline itself. We might or might not have heard about like CK proofs and how powerful they are, but some of the dApps or apps or infrastructures that are CK based, you must have heard of them. For example, Zcash uses CK proofs to hide away the transferees or the transfer amounts happening on the blockchain itself to achieve private transfers of private value transactions using CK proofs. If you are aware of this logo, it's the Dark Forest one. It is a kind of MMO strategy game based on Web3, and it uses CK proofs to hide away like planet coordinates or attack forces informations to achieve an incomplete information gain on top of a fully transparent blockchain. Pretty exciting stuff. So shielding information is one of the values that CK proofs offers. The another one being it helps us kind of compress computations. So for example, CK Sync software uses CK technology to kind of compress and roll up transactions as well as like computations happening on the layer 2 and anchor that proof on a layer 1. Or if you are aware of like Axiom, the project, it uses CK proofs to prove their computation of extracting historical Ethereum states, hence using CK to enable kind of an oracle to the history of Ethereum. So yeah, another value that is offered by CK proofs is the compression of computation, that is. And to fully appreciate the values that CK proofs and CK technology offers, I think there's only one key mindset shifting that is required. That is, we are no longer doing just computations itself, like we are doing with like TypeScript, Solidity, Rust, etc. But now in the CK world, we are actually proving the computation. So what do I mean by that? So in the case of like Zcash, Dark Forest, we're actually proving the computation without actually revealing what is being used to compute the computation. So for example, in Zcash, we are actually not revealing like the transferees, transferers, transfer amounts, etc. Albeit we successfully compute it and prove it and then generate a CK proof for it. And for Dark Forest, that would be the coordinates, the information. And at the same time, we are also proving computation that results in a proof that is nearly constantly verifiable, hence achieving the quote-unquote compression of computation that applies to like CK Sync, applies to Axiom projects, projects that make use of CK proofs for that property. So we are proving computation, but not necessarily just computing things as we used to in the quote-unquote traditional world. And onto the actual pipeline itself, it kind of looks something like that. No worries, we'll go through it bit by bit. It often starts with two entities, one being the prover, the another being the verifier. And to kickstart the whole pipeline, we usually pick one CK tech stack. I'll just use Noir as an example, but there are other great ones out there as well, Circon, Halo 2, perhaps even Cairo, etc. And with that tech stack, you can write your program kind of in CK, which will then generate a proving program and generate a verifying program that is ran by the prover and the verifier respectively. And in the prover side, it would first execute the computation, just like how things are traditionally ran on like computers, smartphones, etc. But on top of that, the tech stack or the proving program would also enable the prover to approve its execution, not necessarily just executing. And that proving would generate a proof that is just like a large byte array, or just, yeah, pure data that is the proof itself, which is then passed on to the verifier. And the verifier with the verifying program and the proof itself can then verify that the proving and the execution was executed either correctly or incorrectly. That's basically it. The verifier would spit out a 1 or 0 answer, and that completes the whole like CK pipeline or the CK workflow. Just to anchor things a bit in more details, we can do a side-by-side demo. Let me fine-tune my screen arrangement real quick. Cool. So let me close my door as well, just to make sure we are noise-free. So if we go back to the pipeline itself, this is how it looks from a high level. And in VS Code, and zoom in a bit, things larger. So we'll be making use of Nargo. Nargo is the kind of CLI tool for Noir to do things related to Noir. But let's start a new project, ETHKL. And if we go into ETHKL itself, we will then see, oh, it should be this folder. We'll then see a source file and a nargo.toml file, which is just like the config. But in the source file, we can actually hold our CK program that is. And by default, it simply generates a main function that takes an X as an input and Y as another input and asserts that X does not equal to Y. That's pretty much the computation. And then if we do generate the input files, say if I put in 1 or 2 as the inputs of X and Y, and we run nargo proof, it would generate the proof itself, which is just a long string of hex data. And at this point, we have already achieved the execute part itself and the proving part itself that generates the proof. And if we want to mimic our role as the verifier, we can then do nargo verify P. And if it spits nothing, that means the verification is successful. But say if we edit the proof itself, then that would not actually be a valid computation or a valid proof. And if we try to verify it, it would tell us that the proof is failed to verify. Reason probably being the proof itself is either corrupted or it was maliciously produced. And so it enables us to verify the computation itself. And that's kind of the role of the verifier in this case. So going back to our slide, we have then kind of just in the last minute or two, mimic the whole ZK workflow from writing our Noir program to execute plus proof to verify on the verifier side. So far, so good. And what's actually the fun part of this pipeline or things that we can play with are playing the game of who to prove and who to verify. Because in fact, the fun part is about the prover and the verifier is often performed or executed by different parties to make things interesting. Starting off, it could be a P2P program where a prover is, for example, Chi, the verifier, for example, is me. And on Chi's end, he could be, say, playing a game and generate a proof of one game move that he's making in the game and sending that proof to me. And I can then verify that he has made a correct step without actually perhaps knowing some of the inputs that he was using to making that game move. Or it could be prover, could be a user itself, and verifier could be, say, a server or a company. In this use case, what would be interesting is, for example, the never-dying traditional ZK metaphor of using ZK to prove your age being an adult. And say, if I'm going to an alcoholic online store, I could be generating a proof on my local end about I am a legal adult in the country that I'm staying in, but not necessarily reviewing what age am I at, and send that proof to the verifier, which is the alcoholic company, and they can safely be assured that they can sell me the alcohol that I'm ordering online. Another thing that's interesting could be the another run. So for example, the prover could be the server, while the verifier would be a local client. If you have heard about Kathy's talk in last month here in ETHKL about zkML, this could be a perfect use case for it, where the prover, aka the machine learning service provider, could be carrying out their machine learning algorithms in a zk proof, and then generating a proof that the request was actually computed and being computed on the machine learning model or the algorithm that they are selling on, and generate that proof and send to the consumer, actually proving that they have legitimately computed the request that the user has requested. And getting perhaps the more interesting part, the prover could be a server, and the verifier could actually be a blockchain or a smart contract. Actually, this is pretty common right now because all the zkRollups would be adopting more or less this model where the rollup itself would be computed and executed on a kind of supercomputer or a large machine, where the rolled up proof would then be submitted on Ethereum layer 1, where the verifier smart contract would verify the state transitions on the rollup. But to the juicy part of today's talk about zk dApps, the exciting thing would be having provers that are being local clients or local users, where the verifier would be the smart contract, and the users themselves can generate zk proofs and interact directly with the smart contract. So this would enable a lot of different use cases. For example, blockchain on-chain gaming, for example, on-chain governance, for example, hiring platforms, etc. We can talk a bit more about it later, but this opens up the zk technology to every dApp developers for users to make use of the technology and play with interesting use cases. To the use cases themselves, for example, Battleships, the team has worked with us on building an implementation in Noir, where the game itself can be played on, if I recall correctly, either Polygon, Mumbai, or an EVM chain that is, albeit the fully transparent chain. They can hide away the lead information themselves and mimic the traditional Battleships games on the blockchain. And Nox is a company that uses Noir and zk technology to build up a Web3 hiring platform for pseudonymous talents. And at the same time, Aragon has also been researching on using Noir to enable trustless zk proving that trustlessly testifies to your ownership of the voting token, but doesn't actually reveal who is actually casting that vote. So yeah, very exciting stuff. Just doing a quick pause to see if there's any questions. If not, we can definitely follow on as well. Oh, live coding. That's barely coding. It's just showcasing.
Seems like we are good, but for those who want to ask questions, I encourage you to put them down the chat so that Savio in progress. Oh, what was that? So that Savio can take a look into the questions and answer them later. So yeah, don't be shy to leave the questions down the chat. Otherwise, you are good.
Yeah,
Savio.
no worries. Oh. Thank you, Chi. There will be a few quick pauses as well, just to make sure we have the time to digest things being shared. But yeah, happy to answer questions if there are any time as well. So far we have covered the pipeline from writing the Noir program all the way to verifying it, as well as the potential use cases of using a smart contract verifier to enable like dApp use cases. But what's the actual caveat behind? The question then arises is, where do we actually store our private variables? So for example, in the Battleships games, the ship coordinates. In the voting example, the voter themselves, or in Nox's cases, the talents informations themselves. Those are things that we would like to keep private. But at the same time, we would like to store it somewhere Web3 so that the actual dApp itself can live fully trustlessly and decentralizedly. But then at the same time, EVM doesn't actually understand or comprehend private states. So how do we actually store private information in an EVM? This then ties to the zkDApp workflow here, where we start by writing the dApp itself or the logic themselves in Noir. For example, dark forest logic, Knox logic, etc. Then we then deploy the verifier on those smart contract chains, for example, Ethereum. And then we would have to actually manage ourselves the private states that we would like for our zkDApps in order to complete the entire workflow of both executing and storing in a Web3 context, which then adds this extra component to the workflow that we mentioned just now, execute, proof, verify. But at the same time, the smart contract that is living on, say, Ethereum would also have to carry out the management of private states. So let's go through what are the components that makes up of a private state management scheme. Pretty straightforward, I would say. Just that we would go through the slide to understand it a bit more. So starting off, not necessarily just private states, but also for every state, usually Merkle tree is a fundamental concept to how they are managed. So a Merkle tree simply looks like that. Leaves at the bottom, boiling up all the way to a root at the top. Leaves at the bottom. And the intermediate nodes in between the root and the leaves would usually be a hash of the components that are below it. So for example, this intermediate node would be a hash of AB, but then it just goes up all the way according to the same logic, F being hash of CD, and the root hash would then be a hash of the EF intermediate nodes. So the merit of Merkle tree is that proving inclusion of certain data would be easy. For example, if I would like to prove that a leaf C definitely lives in this Merkle tree, we would then only need the data of leaf C, leaf D, as well as hash AV to actually compute and match the computation result to the root hash itself. Doesn't seem that intuitive at this slide, but if we're working with a very big tree, we can very soon see the logarithmic advantage of managing states in this manner, where we only need a subset of the information in between to actually prove that we own or there exists a certain data in this whole Merkle tree, rather than knowing all the way from leaf A to, say, leaf C to actually prove inclusion of data. And the question then might arise, if we are storing things on Ethereum where everything is public, how can we make sure things are private then? Then we'll be making use of the concept of hashing, where we'll be specifically making use of the one-way property of hashing. One way being, well, the raw data can be computed into the hash value, but the hash value itself cannot be reversely computed into the raw data that represents the value. And we would still be sticking with the Merkle tree that we introduced just now, but in this case, we'll be adding a private layer underneath the leaves themselves, where the upper half would be the Merkle tree that lives on a public blockchain, where a private part would live under, just to the knowledge of the users. So, for example, we have the raw value A to D. We then hash them to the actual leaves that are living on chain on the Merkle tree, and we then just hash things upwards and complete the whole tree. And in this case, everything stored in the public side would be fully hashed and hence unknown to people that are not involved in the certain use cases about the private values that makes up the whole Merkle tree itself. And then the question pops up again: if everything is private, then how do we actually prevent people double spending things that others might not know? Seems rather unintuitive, right? That brings us to the third component, to the management of private states, which would be nullifiers. We are still making use of hashes, but in this case, we are making use of the deterministic property of most hashing algorithms, which means if we are hashing the same raw data, we would be getting the same deterministic hash results from running the hashing algorithm itself. So A would always lead to 0x AAA rather than leading to a 0x ABAB, for example. And in this case, then we can make use of the property to combined with that hashing property. We can also work with deterministic Merkle trees. So just now, in our previous example, we are kind of just inserting values to the Merkle tree arbitrarily to our liking. But a deterministic Merkle tree, usually a sparse Merkle tree that is very big, would bring about the property of the insertion of data to that Merkle tree is always tied to a deterministic location that is only occupiable to that data rather than arbitrarily to any point on the tree. So for example, if we are carrying a 0x AAA data and we would like to insert it to the deterministic Merkle tree, it can only be, say, for example, inserted to this green box right here rather than any other leaves, locations, or other boxes that are on the tree. So this is the deterministic version of Merkle tree that would be useful for composing nullifiers in a private zkRollup. So how a nullifier works would look something like this. So on the left side, it would be the normal value Merkle tree that we have went through. And on the right side would be the deterministic nullifier tree that we touched on just now. And for example, Alice currently owns a value A on the value tree itself. And Alice would like to spend his value A that is on the tree. She would then compute a deterministic nullifier and insert that nullifier to the nullifier tree, which would then update the record of the nullifier location that is tied to the value node A. And if Alice attempts to double spend her value A, she would then deterministically compute the same nullifier due to the deterministic hashing property of hashes. And she would be attempting to insert the same nullifier at the same location due to the limitations introduced by deterministic Merkle trees. And then the nullifier tree would then understands that the nullifier already exists and prohibits Alice from spending or double spending, in this case, her value node A. So this is how nullifier helps in a zkRollup to prevent double spending of private nodes in the dApp itself. So this would then complete the completer version of the pipeline, where we execute proof on the proof side, and on the verifier contract side, we verify the proof, as well as with the components that we went through just now, we can also manage private states on the smart contract itself. Another quick pause just to make sure things are clear, as well as address questions if there are any. I'll give it a few seconds and take a sip of water. Just to make sure people have time to type it out.
Seems like no one has questions. Probably you explained it really well, Savio.
Thanks, Chi. Yeah, hopefully it helps. And if people are having a hard time following on, definitely let me know. I can go through concepts in more details as well. But if there aren't any questions, we can continue on the slides. So with the concepts covered, both on the zk pipeline as well as on the components that make up of a private state. Let's tie things together with an example that is a private value transfer proof of concept. So in this not necessarily a demo, but in this proof of concept, the objective here would be transferring an unknown amount of quote unquote value to an unknown recipient, but all happening on a Web3 basis or perhaps in an EVM in Ethereum. We'll be covering how it works from a high level, and then on a Noir proof of concept code that we can share with you guys. So in a private transfer dApp, we will be sticking to the Merkle tree that we introduced just now, as well as the hashing that is happening between the private and public boundaries. And in this case, the Merkle tree will be made up of value nodes that has an owner as well as a secret value to keep things secret, where the hash of the node itself would live in the public blockchain tied to a hash commit of the private node, and a value, say, some amount of ETH that is tied to this unspent node that is living on the chain. So let's say Alice would like to transfer 5 Ether to Bob. In this case, Alice would start by owning the value node A, which relates to an ownership of 5 Ether on this blockchain itself. This would be how the state looks like before, and after the transfer, there will be a new node of for Bob that is owned by Bob of a value node 5, and Alice's node would be nullified and no longer be spendable, and this would complete the transfer itself. And to go through the detailed steps themselves, Alice would first have to prove that she owns the 5 Ether. In this case, it would be a Merkle inclusion proof that this hash A do actually exist on the Merkle tree, as well as Alice is actually owning the node underneath, which would require a bit of ZK knowledge to complete this jump of proving between private and public. And then Alice would also have to prove that the node itself is spendable. In this case, that means there's not a nullifier that already exists on the nullifier tree at the deterministic location of her value node A. And then Alice would have to nullify her own node, which is inserting that nullifier to the tree at that position, and deprecating the node that she was able to spend. And she would then create Bob's node that is owned by Bob with the same value. And in this case, the transfer of value is completed within these 4 steps. So if we would like to write the Noir part of this step, brief reminder of the workflow itself, we would be covering this part of the pipeline that can then be written in Noir first. This is how the Noir program would look like. No worries, we'll go through it line by line. But first, we would be defining the main function in the Noir program, which follows with the first input, that is the recipient. In this case, it could be the address of Bob's wallet. And in this proof of concept, we are also using private keys to prove that we own nodes as well as spend nodes. So in this case, we would also be inputting Alice's private key. And then there's the node root, index, node hash path that are the parameters for Alice's node on the Merkle tree itself. There's also a random secret that will be throwing in to prevent brute force attacks on unauthorized expenditure of Alice's node. And then there's also the nullifier tree hash just to compare roots of trees. And we'll start by computing the public key of Alice using the private key supplemented. And we would then hash the node commitment that we would like to add on chain. In this case, that would be the public keys as well as the secret value. And we will be hashing it with the Pedersen hashing algorithm. And then we would be computing the nullifier, which would be another Pedersen hash of the node commitment itself. And then the index that would be inserted in, private key, etc., etc. And we would also perform the Merkle tree membership check. That is the green line proof of Alice actually owning the value node A. So we will be using the hash path, the node commitment, the node root that is currently on chain, etc., to perform the Merkle tree membership check. And then we will be computing the new Merkle tree root due to the insertion of the new node that is now owned by Bob, which would alter the ultimate hash that lives on top of the Merkle tree and return the recipient in this case. So that Noir program would cover the prover part as well as the verifier part, where the Noir program can be executed on Alice's side, and the proof can then be dropped on a smart contract or the dApp smart contract that carries out the verification part of the value transfer from Alice to Bob. And then onto the managed private state part. Won't dive too deep into this because there's more solidity than Noir, but we will start by Noir itself, which fortunately comes with the capability to generate a solidity verifier contract automatically according to the Noir program that is being proved and verified. We'll then expand that verifier contract to a full-fledged private transfer contract that also manages the Merkle trees, nullifiers, hashing, etc. And then we can deploy the full logic onto Ethereum itself and optionally compose it with other dApps out there. For example, swaps, for example, I don't know, voting maybe, as long as there is interest. And if you guys are interested, the full code can also be accessible through the QR code link here. And at the same time, the links to the slide would be dropped at the end. So no hurries on scanning things, if not already. So we've went through some code. We've went through the concepts behind of an example, as well as how things could look in Noir, and the pipeline itself on how to complete from writing the Noir program all the way to deploying on chain. So why have we been talking about like Noir so much? What's so special about it? Let's also spend some time on how, spend some time on learning a bit about what Noir offers and why is it exciting as a zk tech stack to actually achieve what we have went through just now. Before we hop into the language itself, let's do a 5-second spot the difference challenge. And try to see if you can identify the differences between the left side and the right side, being just the color that is behind. But all jokes aside, the left side is actually a Noir program, and the right side would be a Rust program that is written in Rust. This actually brings us to, in my opinion, the most important value proposition of Noir, that is, writing zk programs should be about writing code, but not writing zk circuits like cryptographers do. We do believe that zk technology and zk dApp writing is for everyone, except perhaps the person in the middle of the IQ curve. But what Noir actually offers, do note that we are still in alpha, so things could be changing pretty rapidly. And we are actively adding features as well, so very exciting progress. But yeah, things could be changing. But within the language, Noir offers primitive types. So there will be integers, booleans, strings that you might be used to. We do also have compound types. That's arrays, tuples, and if you are familiar with Rust, then there are also slices, vectors that are more mutable or more dynamic versions of arrays. And we do also have structs that is pretty common in all programming languages. Noir is also capable of doing control flows, if statements for loops. In this case, we are doing an if condition and a 10-time for loop within that increments the count. Noir also offers operators, so we can do comparative operations. We can also do bitwise operations of shifting things, etc. And a lot more. So there are globals, there are logs, there are comments, there are modules that is helpful for organizing code, etc., etc. A lot of exciting features offered within the language itself. But outside of the language, there are also very interesting things that we can play with Noir, starting with tests that can be written and executed in Noir itself. Noir also comes with JavaScript packages that could be extremely useful if people would like to develop zkDApps that comes with a front end, comes with an application that is run that can be run on like computers, mobiles, web browsers, etc. And as mentioned, Noir also comes with the capability of generating solidity verifiers of zk programs written in Noir, which can then be deployed and composed on EVMs and complete the actual dApp workflow of a zk program written in Noir, rather than just an app that runs in a Web2 context. So if we return to this pipeline, the generation of the solidity verifier would be this part of the pipeline, where the proof verification can actually happen in Solidity and on EVMs, rather than just on local computers or servers. And a sprinkle of exciting stuff that is coming to Noir or already in Noir are starting with a rapidly growing set of community libraries. We have community members building out backends that enables like curve operations or whatever applications that requires big numbers. We also have the SESP256R1 library. It might sound cryptic, but if you are familiar with like Web2 use cases or WebAuthn, that is, this would enable zk proofs of, for example, iPhone Touch ID authentication, or for example, Android authentications as well. WebAuthn is actually a pretty common authentication method in the Web2 space. So this would enable us to tie that into Web3 using zk. And there are also community members building out the EC recovery library that enables the verification of ECDSA signatures, that is Ethereum wallet signatures in a zk program. And Aragon's team is also putting together the Ethereum storage proof library that enables us to prove a certain datum exists on the Ethereum history. For example, we can prove that I own, say, a nouns NFT at one point on the Ethereum history, or perhaps I can also prove Uniswap's price was XXX during a certain time on the blockchain at a certain block, etc. So storage proofs enables us to trustlessly prove that from Ethereum's history. And then there is also a RSA signature verification library in Noir that enables us to prove, for example, email headers, for example, signed Git commits, etc., etc. Very exciting Web2 use cases that we can then tie into Web3 using Noir. And another exciting feature that Noir offers is recursion, which just means a proof of proofs of proofs of proofs to infinity, which could be useful for saving guesses. For example, this is actually a a technique that could be used on, say, in the rollup context, or perhaps even in a zkDApp context, where we can then aggregate all the proofs and recursively proof them into one succinct proof that we actually submit on chain. And since verification, it's like roughly constant, albeit the number of proofs that we recursively proved into that final proof, we will be spending the same amount of gas, but then we will be verifying a whole tree of proofs rather than just one proof to begin with. It is also useful for state channels or P2P applications. For example, in the BattleShips case, the player A could be making a proof about his move, which he then sends to player B. Player B would verify that player A was doing a correct move and generate a proof that he would like to make following the previous round, and they can ping pong between themselves the game proofs between rounds and between turns, and at the very end only settle the game with one final proof that is verified on chain to complete the state channel communication, or the P2P game in this case. The recursion would be very helpful and powerful in enabling that. And one more thing, so far we have covered that Noir is capable of handling this part of the things, and we would still be required to manage our private states. But what if we no longer have to worry about like Noir plus the private state Merkle tree plus nullifiers plus Merkle tree plus whatever solidity business logic that we have to build on top of it, and we can just write one elegant Noir smart contract. In this case, the future that we are looking forward to is on a Noir smart contract that not only handles this part, but with a chain or an L2 that adopts Noir as a smart contract language. They can abstract away all the private state management components behind the scene itself, kind of like how smart contract developers only have to deal with solidity, but they don't actually have to deal with like Merkle-Patricia tries, Virgo tries that actually live beneath the hood, and EVM handles all those smart contract data in. And this would be the quote-unquote V2 of zkDApp. So from version 0.9.0 of Noir onwards, we can already write Noir smart contract and compilable into smart contract APIs, which when deployed on a compatible chain, for example, the Aztec rollup that is soon coming, we can directly write everything in Noir and enable a complete zkDApp workflow fully and easily in Noir. And just as a final sneak peek of that interesting feature, this is a zk token that is written in Noir, where you can then see most of the things are the same. For example, the importing of libraries, that's just the same thing with quote unquote normal Noir or OG Noir. But then we will also have constructors like solidity, and we will have, let me see, do we actually see that? I don't think it's actually available here, but we can also have define things as like public variables and private variables that are stored on chain, as well as in, say, UTXO formats, in value node formats, things like that. So yeah, exciting smart contract Noir that is coming. If you would like to get started, I would definitely recommend Awesome Noir as the starter resource. There are a great bunch of talks, workshops, slides that go through the language itself, or dApps that are built using the language. There are a lot of like developer toolings as well, VS Code extensions, boilerplates, libraries, all exist on there, and there are some projects that are written in Noir that's linked on there as well. If you would like to prefer reading code rather than reading words, definitely be my guest. Awesome Noir has it all. And yeah, just feel free to refer to it if you would like to learn a bit more about the language itself. And this would wrap my brief sharing today about not just the zkDApp pipeline, but also a bit on like Noir, how it actually helps tying things together, as well as being a means to enter the zk world, and yeah, write awesome dApps for our users. Happy to take questions if any. Let me see.
Cool. It's okay, Savio. What we will do now is we'll do a quick fireside chat, and then we'll answer all the questions. Most of them by me, some of them other people. Fireside chat is basically just a quick way of getting to know you as a speaker. And I will start off with one simple question, like tell us a bit about your history and how do you get into Web3 and how do you get into zk?
Wow, that's a very long question. I actually got into Web3. I remember now. I actually got into Web3 because of how big of a gamer I was. I was actually a huge gamer fan that checks out literally pretty much every game that was released in the market back in the days. And one of the games that I came across was Gods Unchained, which is a trading card game that uses NFTs as a representation of like virtual trading cards in the digital game itself. Back then, it was living on like Ethereum mainnet, so it doesn't really make sense to play games and draw cards on there. But now I believe they are living on Immutable X, if I recall correctly. So should be a bit more economical to actually pay through the game. But yeah, I found the use of like NFTs to represent digital cards pretty fascinating, because what came before it was like Hearthstones or Magic the Gathering, the digital version that is. Those kind of games never truly shows the value of like ownership of assets, as well as openly tradable versions of digital cards that we used to have in like physical card games. And using NFTs to represent those, pairing it with like OpenSea or whatever open market out there, kind of successfully mimics the physical playthrough, but now on a Web3 context or in a like digital context, which was pretty amazing to me. And so that's how I started getting myself into the rabbit hole of learning about like what NFTs are, what ERC-721s are, ERC-20s then, as well as like what Ethereum is, Bitcoin is, smart contract is, etc. And then fast forwarding for like a year or two from that point, I then kind of have a good grasp of where the space is, and starting to see the pain point being first thing, privacy. That everything living on Ethereum fully publicly doesn't sound fully right to me. And at the same time on throughput as well, because Ethereum can't actually settle that many transactions economically for a lot of people if we are anticipating more to join the community. So at that point then, there are a lot of like talks as well as chats about how zk could be a solution for both. So that's kind of the point where I started getting into zk, as well as learning a bit about zk. And coincidentally, I actually came across the zkU course that, well, Chi, you were in there, but Kathy, that was the speaker last month, actually hosted and coordinated the whole course. And yeah, that was the kind of kickstarting boost to my zk knowledge, as well as getting my hands dirty with coding zk, and then leading to my position now in Aztec on the zk language that we're building. So yeah, kind of an exciting journey, I would say.
Thank you, Savio. I feel to everyone listening, I failed to mention that Savio was one of my mentors in my cohort. I think Savio graduated 1 or 2 cohorts earlier than me, and he was my mentor during that zkU study. And there's a question we have. Let me just jump straight to the question by Us Majafar. If I want to start learning zk and blockchain DC, where should I begin? Another quick background by you, Savio. Were you a developer or were you a computer science student back in uni?
Oh, I actually came from a mechanical engineering background. So the only computer science course that I did was an introduction to Python during my 4 year in university, and that was it. So yeah, I kind of glimpsed over the details, but in between, I also spent some time like self-learning about computer science to get myself at least being able to talk to developers. I won't say I can write good apps at this point, but yeah, at least I know a bit of the concepts there. So to your question on starting to learn CK and blockchain, so I would say learning blockchain would probably come first. I would say there are a lot of great resources online already about blockchain learning, both like written in text as well as in code, if you are interested in learning that. And we can focus a bit more on learning CK. I would say CKU could be a great resource. The course program outline is actually open to access from everyone, but I'm recently also coming to learn about CK Camp. Let me see if I can actually search that up. Oh, yes. So it's a kind of cohorty thing that is run by Breathe, which used to run like Solidity educational cohorts or bootcamp-ish things, but they have been, oh, my internet sucks. But they have been writing some pretty great blog posts on this website as well. And they are going to do a CK cohort where they would then be open sourcing the educational contents that is covered in that cohort. So I would say staying tuned to whatever resources that they are releasing could be a great way to get yourself familiar with CK, as well as in the application of CK in a Web3 context as well. So yeah, feel free to check them out.
Cool. I hope that helped you, Usma Jaffa. And a bit of a more Noir question, something I just decided to skip all the questions and ask this question first. Because creating a language, it's something that creating a DSL, in this case, Noir, I believe is a DSL, if correct me if I'm wrong, Savio? Okay,
right, yeah.
I'm correct, cool. That also means that there is a need for developer to pick up a new language. With the advent of so many languages now in the ZK space, we have Zircom, we have Cairo, and the Starknet community is doing so much to get people to learn Cairo. Does Aztec has a problem getting people to learn Noir or any other efforts besides you giving talks and advocating Aztec? Do you guys have like a program, like a bootcamp or like a hackathon? So what is Aztec's strategy in pushing Noir?
Oh, that's a good question. So the CK Camp thing that I shared just now, they are looking to start a Noir cohort. So feel free to register for that if you're interested. But at the same time, yeah, we are also doing quite a lot of talks and workshops around events as well as online on like just Noir education, as well as on sharing things regarding Noir. We do also have hackathons, but the next one would probably be in Istanbul, if I recall correctly. I'm not sure if we are going for Warsaw, but if not, then yeah, Istanbul would definitely be the next hackathon venue that we will be hosting things. And we do also have a grant program, actually. So if people would like to build out things or try things in Noir, feel free to apply through. My colleagues will be reviewing them. And if we find them interesting, we will be working with you on the ground as well to help you go through the hiccups and learn two things. But I would say the most important out of all, actually, would be the Noir Discord that you can find the link within our docs only, not publicly. So if you do actually read our docs, you will find the awesome community that we have on Discord. It's very close touch, very high signal, pretty much developers only at this point, since we are hiding the link in our docs. But yeah, people are always sharing great insights on there, as well as on like tips and tricks on hacking with Noir there. So yeah, if you manage to read our docs, feel free to jump in and say hi.
This is a massive alpha for those who are watching till this point, including for me. I will definitely catch a link out. So yeah, that's really cool. Back to a couple of Noir questions which I have. I do understand that you had a nice comparison of two functions. One is Noir and one is Rust. At that point of time, I was looking through it. I was like, aren't they exactly the same? And that's exactly what you want to point out, right? You want to show that Noir is exactly like Rust, and people who already know Rust would have zero difficulties in switching between these two languages. Is that I think that is Noir's principle and idea?
Yeah, and we actually do get asked a lot on why building a language at all if we are just doing Rust-like or what Rust equivalent. The short answer to that is that it's just a lot easier to communicate both progress as well as on what are the caveats or different things to other languages if we build a language our own. So for example, when I talk about features, I talked about arrays, tuples. Oops, skip through that slide. I talked about how we have arrays, tuples. This one. I talked about how we have arrays, tuples, slices, factors, etc., etc. But if we are just a month back, we don't actually have slices. We don't actually have factors. We only have arrays and tuples and structs, if I recall correctly. So if we do have our own language and we do have our before that, coding things in ZK is actually very different to just coding things in, say, Rust. Remember, we are not just computing things, but we would also have to constrain and prove the computations themselves. So a slice in Noir, albeit looking the same in Rust, doesn't actually work the same behind the scenes because we are not just executing the slices, but also constraining and proving the computations that are carried out on those slices. And so with our own language, with our own documentations, with our own resources, it's a lot easier to communicate where we are at to the 100% Rust progress bar. For example, now we have arrays, now we have tuples, and when we have slices, we can add in slices. When we have factors, we can announce that we have factors, etc., etc. So communicating progress is one thing. The another thing that perhaps fit into the middle and longer term is about the differences that will be in Noir and Rust. So Noir itself is Rust-like, but it's never going to be Rust equivalent. That's partly because of how things work differently in ZK. So for example, if we talked about primitive types, albeit our recommendation to always stick with integers, but there is also the field type that is in Noir, that is kind of the native type in ZK that is dependent on the proving backend that it uses and the cryptographic curve that it uses. So for example, with the ultra-plong proving backend that comes by default, a field type would be a 254-bit integer. But if we are using a different proving backend, it could be different. But field itself is the native ZK type that exists in Noir, but not necessarily in Rust. And at the same time, we are also adding in smart contract capabilities, as we mentioned. And in that case, there are smart contract syntaxes that would never exist in Rust as a general programming language, but would make a lot of sense to include in Noir for developer experience, for just more intuitive code reading and coding. So for those reasons, that's why Noir itself could be an interesting feat to be in the market, be in the space, just like how we needed solidity for smart contracts. Noir could very much be justified as we need ZK. So yeah, that's pretty much the reasoning behind.
That's a great answer, as expected from product manager working in Noir. I do have a couple of things to point out and ask. Like you mentioned that slices are basically synthetic sugar over you declaring some variable and constraining it. So the developers using it don't have to think about the constraints behind the scene. So I'm wondering if there is still a need to write constraints. For example, if you're performing maybe a square root of maybe square root of a very complex number. At this point of time, it's basically much easier performing the reverse and then constrain it so that the output of the square root is constrained. So will we be able to do the same thing in Noir, and how does it probably look like?
So in Noir itself, so for now, whatever that you write in Noir by default is already constrained behind the scene. So in your example, since it is a kind of a simple optimization, I believe the Noir compiler would automatically optimizes that step as well as constraining that step as according to how you described it. But for more advanced ways of writing logic in Noir, with the 0.9.0 release, we are also offering unconstrained functions. So people can actually, hopefully only advanced users that knows what they are doing can then write unconstrained executions within Noir that doesn't automatically get constrained, but then they can lay out the constraints themselves for those unconstrained code excerpts. And in order to achieve like more complex optimizations for their programs or for their logic. And that would be kind of the like advanced side of things. But yeah, by default, everything written in Noir would be already constrained behind the scene.
Nice. So everything is very safe to use, meaning that should you write it normally without doing some fancy operations that I like, for example, the one I'm saying about, it's very safe and everything should be constrained.
Exactly, yeah.
Nice. This is a very cool feature to have. And the unconstrained kind of feature reminds me a lot like the hint part in Cairo, which is something that they now do not allow people to do it by default. And I'm happy to see that Noah has it, and I will do it in Noah. I hope that no one from Cairo time is listening to this.
Yeah, like minds think alike.
That is super important, right? And yeah, I do personally have a couple of questions. We got 20+ minutes, plenty of time. I hope you have time too, Savio. So in Rust, one of the things that people find a bit weird is that there are things like lifetime, there are things that you need to drop, there are things like dropping the reference, there are things like referencing immutable reference. Are all these concepts available present in Noir?
Yeah, at this moment, I would say they aren't fully present yet, but we are working on getting those into Noir just to make sure we complete kind of the feature set that is offered by Rust and enjoyed by Rust. Certainly it's tricky to comprehend, but they are definitely useful in the programming context as well. So fingers crossed that we can do a better educational effort than Rust's docs or materials, and we can actually get those concepts boiled down pretty clearly for our users to, yeah, actually take advantage of them instead of getting annoyed by them.
True, and that the concept of traits and impulse are also very Rust-like. Does Noah has those traits and impulse? Because it's nice that you have a trait and you can just implement it and stuff like that.
We don't currently have it yet, but we already are working with a team to introduce that. So yeah, soon trademarked.
Nice. I'm asking very good questions here, and I'm proud of it. And you mentioned ultra-plonk being the proof system under the hood. And I learned that Noir basically is a language, like it's a front-end language that supports a variety of proof systems. Because it compiles down to an IR, and IR only needs to support whatever proof systems it runs under the hood. Correct me if I'm wrong, Savio. Good, I'm right. Fantastic. I'm happy that I'm quite right. Have anyone implemented any sort of other proof systems aside from ultra-plonk?
Yes, there is and there was. So at some point, we actually had the Marlin backend as well as a general Arcworks backend, if I recall correctly, that works with the intermediate representation and the Noir itself. We kind of deprecated those since we are shifting focus. But at this point, there are also two teams working on one, the Noir backend that is built by Consensus or Gnark, if you pronounce the G. And there's another team that is also working on Halo 2 integration with the Noir tech stack. So if you actually go to, right, Halo 2 backend, this repo.
I kind of see Halo 2 coming up as already in my head. I was like, someone should write for Halo 2. Because Halo 2 is just so hard to write in Rust. Actually, not hard, but very difficult to write in Rust. And Noir could be good.
Yeah, that's what we have been hearing, but people do miss the performance that it offers. So hopefully tying it into Noir will offer the best of both worlds. But yeah, there's the team that is working on Halo 2 integration. I believe they are aiming for PSE's flavor of Halo 2 first, but they are also working on Axiom's version in parallel. So yeah, exciting stuff ahead.
Exciting stuff ahead indeed. And how does lookup tables look like in a version of Halo 2? I think UltraPlong probably supports lookups, right? Because UltraPlong is one of those new Plong and Plong. Advantage of the Plong is lookup tables. How does lookup table look like in Noir? How do you declare lookup table?
That's a very good question. So right now we don't directly expose the lookup tables themselves, but if you define a dynamical array in Noir, behind the scenes, it actually makes use of lookup tables already. So yeah, we can kind of mimic it as an array in Noir rather than defining the whole table itself.
So interestingly, you try to mimic lookup tables using array, but why not you mimic using maps or mimic using mappings? Would those make more sense? I know you probably know more, and I just randomly throw questions to you. But wouldn't maps make more sense because map is like lookup as well?
Yeah, that's a good point. Perhaps we would be introducing maps as a syntax later down the road, but I would say immutable arrays are kind of like maps, I guess. So yeah, let's see. We can definitely
key value, right? Key value is something like
we can definitely think through that as well. Yeah, maps could make sense.
Cool. I would like to see my name in the contribution list. Should maps? No. Fantastic. Let's see what other questions. I basically asked a ton of questions. Oh, you mentioned that storage proof library is being written or has been written by the Aragon team. Would that effectively put Axiom out of business? And Yisan, if you're listening to this, I'm sorry.
Axiom is still a bit ahead than us too. So the library itself currently only proves the ownership of a noun's entity is kind of hard-coded, as well as tied to certain smart contracts, etc. So right now, what it proves is a noun's ownership at a certain block, and that's pretty much it. And if we manage to generalize it a bit, then we can do general storage proofs of things. But I believe Axiom doesn't only do storage proofs; they also do account state proofs, or there are a few different trees within Ethereum, and they do proofs on all of them. And in this case, it is only storage proofs. So by feature set, we are still pretty far behind, as well as on like developer experience, since they are focusing more on exposing those as a kind of solidity API, you could say, where people can directly call through smart contracts. Where in our case, we are still like verifying the proof in a solidity environment, and it might require quite a bit of additional works to make it as friendly as Axiom's tech stack. But I would say the interesting part of like Ethereum storage proofs in Noir would be how composable it is with other Noir libraries, with other Noir programs, and you can actually plug it into like different dApps written in Noir rather than just calling it on Solidity in Axiom's case. So they're kind of serving different needs, albeit originating from the same technology, that is.
Cool. Thanks for clarifying that. Basically, I got another question. How are witnesses being written for witnesses being our private inputs in Noir? Because we know that
right.
be a private input, and how do you like? Oh, so without the pub keyword, it will be a private input by default. Is that what you're trying to say?
Yes. So if we look into the example code that we shared, you could find some of the inputs are defined as pub and some aren't. So by default, things are always private unless you declare them as pub, which stands for public. And in that case, the input value itself would be incorporated as well as tied into the proof that is generated. And so the verifier can access those public inputs as well as return values on the verifier side, not just on the proof side.
Cool. I'm going to jump ahead to some other people's question because I'm asking my question. Victor asks, which zkEVM is built with Noir, or which chain is built in Noir? Anyone uses Noir to build a roll-up for now?
Wow, I would be looking forward to that. But at this moment, I don't think any EVMs or chains are built with Noir. There is a zkEVM project that is more of a like experimental thing rather than legitimately building out a chain in Noir. But yeah, definitely looking forward to seeing that being built in Noir if someone is interested to check that out.
I'm thinking of how it will look like. I'll think of it later. So actually, speaking of which, speaking of zkEVM, now this is a related question. Back to my question again. So building a language itself is, let's be honest, it's not profitable. We need to convince people to use it. People don't like. You cannot. There's no business model in building a language. So what is the plan or goal of Aztec to build Noir? Like, I know Aztec from building a language. I know that Aztec is trying to lay some brickwork to building something. Could you perhaps expose to us or leak a bit of alpha if we didn't knew what you can say about Aztec's goal using Noir?
The juicy 100 million question, huh? So yeah, in fact, simply building a language itself would not really make sense as a business model. But in our case, we are building Noir as a both proving backend agnostic language as well as chain agnostic language once it is extended with smart contract capabilities for the bigger purpose of growing the entire zk pie, because we do see how kind of limited in terms of like the zk talents, zk developers, zk dApps that currently exist today, versus what the technology can actually offers for the bigger public, for people that might not even have heard about Web3 at this point. So kind of aiming Noir as a kind of public good as well as an agnostic good would be helpful in just growing that adoption, growing that snowballing effect for the bigger zk space. And in Aztec's point of view, so our main business or the bigger engineering team, apart from the Noir team that lives within Aztec Labs, is working on Aztec zkRollup. So that is the L2 that supports not only public states like Ethereum, like no offense, Stocknet, like zkSync, but also private states that enables the very different design space zk dApps could tap into. Ones that is a bit more intuitive to work with, as well as people learn about it. So Aztec would very likely be the first rollup or the first chain that adopts Noir as its smart contract language. And yeah, at that point, we'll be competing with whatever chains that would like to adopt Noir as its language. And hopefully Aztec can deliver the best developer experience and succeeds from that point onwards.
Very cool. And back to that pretty much answered Victor's question, which zk is built with Noir. It won't be zkEVM, but it will be zkEVM that's built in Noir. It's going to be by the Aztec team, right? Right, Savio? That's what you guys are planning to do?
Yeah. At this point, we're still building things in C++, unfortunately. But yeah, down the road, we will probably be integrating more tightly with Noir. Not only developers are building using Noir on that zkVM, but also that zkVM could be partly built using Noir itself as the proving language. So yeah.
Cool. Before I jump onto my final question, I have to ask. We are 7 minutes away. We're playing out of time. One more. I do not want to ignore Harish's question. He asked, can I incorporate zk use cases into small business usage like F&B? I'm going to take that because it really depends on how you want to use it. Like context, you definitely can use zk everywhere. It depends on how you want to use it. So I'm not going to let Savio answer this because this is the way your question is a bit unclear. But you're free to clarify them in the question in the message box, and I'm more than happy to ask them again. Oh, but he left, so he can't clarify. So, okay, back to my question. You mentioned zk dApps, and you also mentioned Ethereum being a public state chain, and dApps like Uniswap, like a lot of swaps, they are very easy to be done in the public space because they're storing the storage root, and then people are able to examine the states and perform whatever swap they want. Like, how will this look like? Because we won't be maintaining storage roots anymore. how will this look like in the world of Aztec, where there are private transactions, private DEX, or has this all been thought out already, or not?
Yeah, that's a very good question. We actually spent quite a bit of time last year thinking through that. And the takeaway from that kind of brainstorming is that we can't live solely as a private rollup, but we have to live as a hybrid rollup that supports not just private states, but also public states whenever that is needed. So for example, in a token swap scenario, if everything is public, it's easy to do. Like I can directly swap with the Uniswap pool, and someone can directly swap with the Uniswap pool, no problem there. But if everything's private, how do I actually know, for example, the price that I'm swapping with? How do I actually know the liquidity that is available? That's pure impossible. And the beauty of zk dApps would probably lie right in between of that spectrum, where some of the variables are public, some of them aren't. So for example, if we are doing a zk token swap, the price itself could be public. The total liquidity could be public, depending on the design. But then the actual swappers themselves could be private. That would make things a lot more interesting. So I could privately swap either to USDC successfully according to the public market price, but not necessarily reviewing that I am the one that is swapping, as well as if I'm sending it to another address, that another address wouldn't be directly associated with that trade as well. So yeah, that would be how a private swap could look like, say, on Aztec or whatever hybrid blockchains out there.
Another question, follow-up question on for mine is that what if you, let's say the price has to be public because people kind of need to know the price, liquidity, I don't know yet, probably has to be public as well. But wouldn't you be able to infer like the amount of token being swapped because the price and liquidity is public, and then you make some math, and then you infer that, oh, this guy is swapping how much token to that token, and because the address not be public, has to be public because it comes from the address. I don't know if this has been thought out or before, or something that's even worth asking. What do you think?
Yeah, that's very true. So the amount itself could be a public information, albeit in every specific swaps, but the swapper itself would be private. So fundamentally, things could be private, assuming that the user is like careful enough not to swap like very unique amounts that is only tied to his or her deposit onto the chain, etc., etc. And that part of the privacy equation would probably best be solved at the like front end interface level that reminds users about like best privacy practices, as well as perhaps guiding them through those processes rather than having them to spend the big brain power on thinking through managing, splitting the trades into like sums of tens, etc., etc. But yeah, fundamentally it can be kept private, and albeit the amounts being public. It's kind of similar in the voting scenario as well. So for example, if we would like to do a private vote, there are two ways to achieve that. Either the amounts or the direction that we are voting yes, no is being hidden from public, or the voter themselves can be hidden from the public. And hiding the amounts or hiding the voting preference could be tricky unless we incorporate like homomorphic encryption, etc., that we can actually tally results in an encrypted format. But if not, then the approach would usually lie on to hiding the voters themselves by being known like a yes vote was casted, a no vote was casted, etc. So yeah.
Actually, just point out a problem I'm trying to solve regarding voting. And homomorphic encryption is something that I'm wondering if Noir has in the library.
Oh, right. So I won't say we have an out-of-the-box library for voting, but the Aragon's research on Ethereum storage proof is actually a part of the bigger research on doing trustless private voting on the Ethereum. So, but in addition to that, we do also have the Noir starter repo. Let me find that. Oh no, not Noir starter, the Noir example repo. And in there, there's a voting. There is a voting example, if I recall correct. Oh yes, Foundry voting. It's a like basic implementation of voting using Noir. More is a showcase and proof of concept rather than the full-fledged app itself. But yeah, if you would like to learn a bit more about how private voting could be done, this could be a good starting point. And moving on to Aragon's research, we can read through the whole proposal as well as on their progress reports on understanding the minute details, the technical complicacies regarding private voting. But yeah.
Cool. Thanks for sharing and sharing a lot of good resources. There are some of us still left, but I'm sure there are a lot of people who's going to watch the video afterwards. Any words that you want to say to our viewers about Aztec, about Noir? How do you encourage people to get involved? How should people get involved? Yeah, take it away.
I don't really have any great advice. I would say just in a short answer, don't fear about ZK. So far, we might have heard about like, I have to learn Rust, I have to learn about circuits. And actually, if you do find like ZK courses online, a lot of them are very math heavy, very cryptographically heavy, and things could look scary. I would say we are no longer in that historical state with like Noir, with like Aztec, as well as a lot of great toolings out there. We can actually write ZK programs fairly easily, just like normal programs, but then we can tap into the ZK values, advantages that we have been hearing so far ourselves. So yeah, get hands dirty and try coding.
Try coding with Noir. Drop a feedback to Savio and the Discord channel. And I probably these are things that the Noir devs would like to know, right? Like feedbacks from the community, like what can we improve and whatnot. Or
for
even
sure, for sure.
Yeah, or even OP. I don't know if you guys would welcome public contributions.
Yes, definitely. If you would like to submit an issue, fully appreciate that. And if you would like to submit a PR, fully appreciate it for that as well. And if you would like to join the team, definitely check our website and find the openings there.
Cool. You guys are hiring too. I don't know. Do you want to open a page to let people know that you guys are hiring? More than happy for you to do that if you want.
Yeah, we are hiring. If you go to aztec.network and go to the careers page, you can find the open roles there. I believe we have at least one opening for, yes, we have a compiler opening, albeit a bit focused, but we have other openings for the Aztec teams. I believe some are coming up for commercial teams as well. So yeah, stay tuned for that and do apply away if you're interested.
So that probably sums up. We are at 9:32 both our times. And I took 1.5 hours away from you already, Savio. And I'd like to thank you so much. Thank you so much for sharing all these very useful details. I personally learned a lot about Noir. I'm sure many of our listeners learned a lot too. Thank you so much. Victor says thanks. Seth says thanks. Thank you so much, and I appreciate it. Any last words? If not, we shall call it a day.
Thank you all for bearing through the talk, and thank you for the invite. Fully honored to be here and sharing things with you guys. Definitely looking forward to the mutual sharing as well. So definitely let me know if interesting things are happening in your circles, not just you, Chi, but also everyone on this call, as well as everyone that is watching the recording. Ping me on Telegram, on Discord, on Twitter, whatever. Happy to connect.
Yes, and I will also include the slide link, which Savio has shared with me before the talk, into our ETHKL Telegram group. Savio, are you in the group already? If you want to be in group, I can give you an invite and people can ask you questions. Sounds good, I'll do that. And we'll also include this slide link into our YouTube description, which will come afterwards because it's now being recorded. Aside from that, I hope everyone had a great day. Savio, you have a great day. If you have not had dinner, please go for the dinner. And I'll go for dinner myself. Thank you, everyone, and I will see you guys in the next one.
Thank you. Take care.
You too.